Hello everyone. Today we are going to discuss carbohydrates. The carbohydrates can be classified into three types mainly: monosaccharides, oligosaccharides, polysaccharides. Okay. The monosaccharides are also called what? Simple sugars. Okay. And mono indicates what? One. So one saccharide unit will be present here, which are called simple sugars. Again, the monosaccharides will be having what? Different types of functional groups here. Suppose if monosaccharide contains aldehyde functional group, it is called aldose. If monosaccharide contains aldehyde, it is called aldose. Okay, example glucose for that. And if ketone group is present, that is called what? Ketose. So ketose and aldose, two types we can divide. So monosaccharides will be of two types based on what? Functional groups: aldoses, ketoses. For aldoses, example is what? Glucose. And for ketose, the example is fructose. And we can classify the monosaccharides into different types based on what? Number of carbon atoms. Suppose if you take number of carbon atoms 3, that carbohydrate is called what? Triose. Here OSE, O's indicates what? Sugar. So monosaccharides will be of different types based on number of carbon atoms present in each molecule. If each molecule contains 3 atoms of carbon, triose. Example what? Glyceraldehyde. If 4 carbons present, tetrose. Tetra means what? 4. Tetrose. And example erythrose for that. And if 5 carbon atoms present, that is called what? Pentose. Pentose example is ribose. And hexose. Example what? Glucose and fructose. Hexa means what? 6 carbons. So here 6 carbons, 5 carbons, 4 carbons, and 3 carbons will be present in different types of monosaccharides. The second type of carbohydrates are oligosaccharides. So these oligosaccharides contain 2 to 10 saccharide units. The sugar units are also called what? Saccharide units. So how many saccharide units are present here? 2 to 10 saccharide units are present in oligosaccharides. Example, if 2 saccharide units are present, that is called disaccharide. If 3 saccharide units are present, trisaccharide. If 4 saccharide units are present, that is called what? Tetrasaccharides. If sugar units are 5, suppose, pentasaccharides. So like this, what now here? Based on the number of saccharide units, we can classify oligosaccharides into di, tri, tetra, penta, hexa, like this, up to deca, decasaccharide. If 10 sugar units are present, that is called what? Decasaccharide. So mainly we use what now here? Disaccharides, example what? Maltose, lactose, sucrose. And trisaccharides, example is what? Raffinose, Raffinose. Raffinose. And tetrasaccharide, example, stachyose, 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 stachyose. OSE indicates what here? Sugar. The suffix OSE indicates sugar molecule. So stachyose is an example of tetrasaccharide. How many sugar units will be present in this? 4. And in raffinose, how many sugar units will be present? 3. That means the 3 saccharide units present in raffinose and 4 saccharide units will be present in stachyose. And here it is got verbascose. Okay, verbascose is what now here example for pentasaccharide. It contains how many? 5 sugar units. Next, the third type of carbohydrates are what? Polysaccharides. So these polysaccharides contain what? More than 10 sugar units. More than 10 sugar units will be present in polysaccharides. Here we can say that if you hydrolyze this polysaccharide molecule, if you take example starch, suppose the starch molecule, when it is hydrolyzed, it will give more than 10 sugar units. On hydrolysis, each starch molecule will be giving more than 10 sugar units. The sugar units are also called what? Saccharides. That's why it is called poly. Poly means many. Many saccharide units will be given by the hydrolysis of each molecule of polysaccharide. Okay. So here again, the polysaccharides will be of two types: homopolysaccharides, heteropolysaccharides. In the name itself, it is clear. Homopolysaccharides meaning what? The total polysaccharide molecule is made up of only one kind of molecule. Suppose starch is made up of glucose molecule. The total starch is made up of what? Glucose molecules. So only one kind of monosaccharide units will be present. They are called what now here? Homopolysaccharides. So homopolysaccharide contains many similar type of saccharide units. So examples for a homopolysaccharides what? Starch, glycogen, cellulose, chitin, 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 and insulin. Okay, insulin is given here, insulin. So insulin, chitin, cellulose, glycogen, starch. These all are examples of what homopolysaccharides, which are made up of only one kind of saccharide units. And second type is what? Heteropolysaccharides. The heteropolysaccharides, examples what now here? Peptidoglycan. That means what now? Hetero meaning what? In each polysaccharide, more than 10 sugar units will be there. But all sugar units will not be same type. Different types of sugar units will be forming what? Heteropolysaccharide. So heteropolysaccharides example what here? Peptidoglycan. Next, hyaluronic acid. Hyaluronic acid. Next what here? Con chondroitin sulfate is it. Chondroitin sulfate. Next, keratin sulfate. Agar, one type of gel. So these all are examples of what? Heteropolysaccharides. So like this, different types of carbohydrates can be classified in this form. So it is what now classification of carbohydrates. Next, monosaccharides. Okay, so these are the simplest one unit, non-hydrolyzable sugars. Non-hydrolyzable sugars means what? They cannot undergo hydrolysis. Monosaccharides cannot undergo hydrolysis. So they are non-hydrolyzable sugars. And they are made up of how many units here? Only one type of unit. Only one type of monosaccharide unit will be present here. And they have general formula what? CN, H2N, ON. N is number of carbons and N is again oxygen number. And hydrogen number is equal to N. Yeah. Where N value varies from 3 to 9. N value changes from where to where? 3 to 9. If N value 3, what is the formula? C3, H6O3. If N value is 6, suppose C6, H12O6. Like this. So about 20 monosaccharides are present in the nature here. So how many monosaccharides are available in the nature? Totally 20 monosaccharides are present. So the simplest monosaccharides example what? Trioses. Trioses contain how many carbon atoms? 3. The example of triose is what? Glyceraldehyde. Glyceraldehyde. Okay, it is an aldo triose. Aldo meaning what? Aldehyde group is present. Triose means what? With 3 carbons. The sugar with 3 carbons. So here it is, you see, CHO is there here. CHO means what? Aldehyde. CH double bond O. Aldehyde group. So this group is nothing but aldehyde functional group. And CHOH. Read from top to bottom. CHO, then CHOH bond CH2OH. It is the structure of our glyceraldehyde. Glyceraldehyde. And next one. Here you see 1, 2, 3 carbons available here. Okay. Actually, it is CH3 double bond CO double bond CH3. If it is CH3, CO, CH3, what is that called? Acetone, we say. CH3, CO, CH3. Suppose if it is like this. CH3 bond, CO bond, CH3. What is this called? It is example of, it is a molecule of what? Acetone. Acetone. So this acetone molecule is this. Here one OH group is substituted here. Here also one OH group is substituted. In acetone, how many hydroxy groups available? 2 hydroxy groups. So it is called dihydroxy acetone. Dihydroxy acetone. And it is an example of what? Keto triose. Keto means what? Ketone group is present. And triose means what? The sugar with 3 carbon atoms. So let's put now here dihydroxyacetone and glyceraldehyde. Both are examples of what? Monosaccharides. And other examples of pentose is what now here? Monosaccharides, ribose with 5 carbons. And 2 common hexoses will be glucose and fructose. Glucose and fructose, each molecule contains what? 6 carbon atoms. So it is called hexose. And ribose contains how many carbons? 5. So it is called pentose. Okay. Next, disaccharides. Here, disaccharides means how many sugar units will be present? 2 sugar units. That is called 2 saccharide units will be present here. So on hydrolysis, they give how many sugar units here? 2 molecules of same or different monosaccharide units. So 2 different or 2 same monosaccharide units will be given on hydrolysis of which molecule? Disaccharide. A disaccharide means how many carbons will be there? C12. If C6 is there, monosaccharide, C12 is there, disaccharide, C18 is there, it is trisaccharide. Like that we can say. Here example is given what now? Sucrose. Okay. Now here the sucrose molecule on hydrolysis. This reaction name is what here? Hydrolysis. Hydrolysis. So on hydrolysis of sucrose, on hydrolysis of sucrose molecule, we get 2 different molecules here. 2 monosaccharide units what we got? One is glucose, one is fructose. Both are having same molecular formula. But what is the difference? The glucose is an example of what? Aldose. Here aldehyde group will be present. And the fructose is an example of what? Ketose. It is containing ketone group here. So aldose and ketose. So we got glucose and fructose from sucrose. On which process? On hydrolysis process in acidic medium. H plus indicates what here? Acidic medium. Okay. And now if you take maltose, it is also what now here containing C12 now. C12 means how many saccharide units? 2 saccharide units, 2 sugar units will be present here. So this maltose on hydrolysis process will again give what now here? Will 2 units here. The 2 monosaccharide units are of same type. Glucose only will be there. Here no fructose is produced here. So same kind of monosaccharides are produced by the hydrolysis of maltose. So this reaction is also what again? Hydrolysis or hydrolysis. So on hydrolysis of maltose, in the presence of acidic medium, we are getting what now here? 2 molecules of glucose. Okay. So 1 mole maltose is giving 2 moles of glucose. But 1 mole sucrose is giving what? 1 mole glucose and 1 mole fructose on hydrolysis process. Next, 1 more disaccharide example what? C12, H22O11. See the 3 molecules, sucrose, maltose and lactose. All are having same molecular formula, you see. All are undergoing which process? Hydrolysis process. In which medium? Acidic medium. Then we are getting what again here in this case? From lactose, we are getting glucose molecule and galactose molecule. Again, galactose contains the same formula. It also has what same molecular formula? C6H12O6. So like this formula here, galactose and glucose are produced as monosaccharides from the lactose molecule. Next, trisaccharides. A trisaccharides contain how many carbon atoms? 18. Okay, 3 into 6. 18 will be there here. 18 carbons will be present here. And always remember that the oxygen number will be half of hydrogen number. Oxygen number is 16 here. It is half of what? 32. So H32O16. Okay. Now here on hydrolysis process, on hydrolysis reaction, how many sugar units will be forming here? 3 molecules. 3 molecules of same type or different types of monosaccharides will be produced by the hydrolysis of what? Trisaccharides. Trisaccharides example what here? Raffinose. Raffinose. So raffinose formula what? C18, H32O16. So this raffinose is undergoing what? Hydrolysis. So each trisaccharide requires how many water molecules? 2. Each disaccharide requires 1 H2O. Each trisaccharide requires what? 2 H2O. In the presence of again which medium? Acidic medium. The raffinose undergoes what? Hydrolysis process and gives what? Glucose, fructose, galactose. So 3 monosaccharides are produced here. 3 sugar units are produced here. What are they? Glucose, fructose, and galactose. Each molecule contains 6 atoms of carbon. It is hydrolysis of what? Raffinose. Next, tetrasaccharides. Tetra means how many carbons will be there? 6 into 4. 24 carbons will be present in one molecule. In each tetrasaccharide molecule, how many carbon atoms will be present? 24. Okay, C24, H42, O21. Here oxygen number will be half of hydrogen number. Here oxygen number 21, which is half of 42. Okay, so this tetrasaccharides on hydrolysis will be giving how many? 4 molecules of same type or different types of monosaccharides. Example what here? Stachyose. Stachyose is an example of tetrasaccharides. Here, the stachyose molecule, when it undergoes hydrolysis, how many water molecules are required here? The tetrasaccharide requires what? 3 H2O. Trisaccharide requires how many water molecules? 2. So here, 1 molecule or 1 mole of stachyose requires 3 moles of H2O in the presence of acidic medium. And this is what acidic hydrolysis we can say. Acidic hydrolysis will be giving what? Glucose molecule, fructose molecule, and 2 molecules of galactose. 2 moles of galactose, 1 mole of fructose, 1 mole of glucose are formed from stachyose. And then polysaccharides. In the name itself, it is a poly. Means on hydrolysis, generally they are called what? Non-sugars. Means they are not sweet in taste. They are called non-sugars here. So on hydrolysis, they will be giving what? Large number of monosaccharide units. The large number of monosaccharide units will be formed here. N number of molecules are produced by the hydrolysis of one polysaccharide molecule. Generally, the polysaccharide molecule, example starch if you take. Formula of starch what? C6H10O5 taken N. That is what starch. What is the formula of starch? C6H10O5 taken how many times? N times. Taken N times. So it is starch here. And generally N is what now here? 100 to 3000. The N value is what now? 100 to 3000. That means 100 molecules to 3000 molecules will be joining with each other to form polysaccharide unit. Okay. The examples of polysaccharides what? Starch, cellulose, inulin, glycogen. These all are examples of what? Polysaccharides. Now here, starch requires what now here? N number of water molecules to give N moles of what now? Glucose. Okay. So here, whatever the N number, whatever the N, that many moles of glucose will be produced here. That means a starch is made up of only glucose units. So starch is an example of what? Homopolysaccharide. Homopolysaccharide. Okay. And cellulose formula also same. The cellulose also has same formula C6H10O5. Remember. So having same molecular formula and different functional groups and different structures are called what? Isomers. So glucose and fructose are what? Functional isomers. Functional means they differ in functional group here. Molecular formula is same. Next, some examples of carbohydrates you see. Aldo, triose. Where ose means what? Sugar molecule. Tri means how many carbon atoms in each molecule? 3. Aldo indicates what? Aldehyde. So aldo, triose. Example what? Glyceraldehyde. And keto, triose. Keto, triose. Example dihydroxyacetone. Dihydroxyacetone. And then aldo, tetrose. Okay. Aldo means aldehyde group here. Tetra means what now? 4 carbons in each molecule. Ose indicates what? Sugar molecule. So the sugar molecule with 4 carbon atoms containing one aldehyde group. Example, erythrose. and triose. Erythrose and triose are examples of aldo tetraoses. Next, keto tetrose. Ketone group will be present in this tetrose. Example what? Erythrulose. Erythrulose. Erythrulose is what now here? Ketose, theta tetrose, and erythrose is what? Aldo tetrose. Next, aldo pentose. Aldo pentose. Example what? Arabinose, arabinose, ribose, xylose, lysose or lixose. So lixose, xylose, ribose, arabinose are examples of aldo pentose. And this ribose will be present in what generally? RNA and DNA. DNA stands for what? Deoxyribonucleic acid. And here ribonucleic acid. Ribonucleic acid, here deoxyribonucleic acid. So ribose sugar will be present in the ribose sugar. Next, ketopentoses. Ketone group is present and 5 carbon atoms present in each molecule. So example what? Ribulose. Ketopentose example what? Ribulose. Ribose is aldopentose. Ribulose is what? Ketopentose. Next, xylulose. Xylulose. Xylose is what? Aldopentose. But xylulose is what? Ketopentose. Functional group is changing. Next, aldohexose. Aldohexose. Example what? Glucose, mannose, allose, altrose, gulose, idose, galactose, allose. These are all examples of what? Aldohexoses. And ketohexose. Ketohexose. Ketone group will be there and 6 carbons will be present. Fructose, sorbose, tagulose. These all are examples of what? Ketohexose. So these are some of the examples of our carbohydrates. Next, if you take glucose molecule. Glucose formula what? C6H12O6. Now here 6 carbons are directly linked. C bond, C bond, C bond, C bonds. That is 6 carbons directly attached to each other. So how many carbon chain it is? 6 carbon chain. 6 carbon chain is present here. And if you take this carbon, this compound over here, see, this first atom, it is what? Second atom. This one, third atom. Fourth, fifth, and sixth. So how many carbon atoms in the longest chain, parent chain? 6 carbons present here. The first atom, second atom. Now see, the first atom contains what now? Double bond now. Here C, double bond O will be there, single bond H will be there. Like it is what now here? C, double bond O, and single bond H. So the double bonded carbon cannot be chiral. It is what? This carbon cannot be chiral. So not chiral. It is not the chiral carbon, the double bonded carbon. And this carbon is chiral. This carbon is chiral. This carbon is chiral. This carbon is chiral. So how many chiral carbons? 1, 2, 3, 4 there. And this is not chiral. Last one. Why? On the last carbon, sixth carbon, 2 hydrogens, same type now. 2 hydrogen atoms present. 1 OH group is present. So when 2 atoms are same, that carbon cannot be chiral carbon. So sixth is not chiral. So how many chiral carbons in glucose? 4 chiral carbons. So in glucose, how many chiral? 4 chiral carbon atoms. 4 chiral carbon atoms present in glucose molecule. Chiral carbon is also called what? Asymmetric carbon. Asymmetric carbon we have to say. And next thing, try to understand. Next thing is that, see, it is first chiral. This is what now? First chiral carbon. First chiral carbon. And this one is what? Last chiral carbon in the glucose molecule. How to read from top to bottom? Tell me. First, we read CHO bond. CH, left side H is there. OH bond. COH, left side now. COH H. Again bond. CHOH. Again CHOH. Lastly CH2 OH. So this is a glucose molecule. So first chiral, last chiral. Now in the first chiral carbon, on the first chiral carbon, left side, what is there? Hydrogen is there. Hydrogen atomic mass, how much now? AMU, how much? 1 AMU. In AMU, how much atomic mass of hydrogen? 1 AMU is there. And what is the atomic mass of OH here? Means what is the mass of OH group here? 17 AMU. Why 17 AMU here? Why 17 AMU in this case? Oxygen 16, hydrogen 1. 16 plus 1, 17 AMU. So 17 atomic mass unit, here 1 atomic mass unit. Now, what we have to do is that we have to draw the curved line. We have to draw the curved line from OH to, from H to OH, from lower mass to higher mass, from lower mass hydrogen to higher mass OH group. We have to draw one curved arrow from the top of CHO. Above the CHO, we have to draw one curved line from hydrogen to OH group. That means from lower mass to higher mass. Now this line, curved line, is going clockwise,ly, anti-clockwise,ly. The line is going clockwise,ly here. Clockwise,ly means it is plus configuration, remember. Plus configuration. Plus means what? Dextro rotation. Dextro rotation means what? Right side. This molecule now, this glucose molecule will rotate the plane polarized light. This molecule will rotate plane polarized light towards which side? Right side. That's why it is called small d. Otherwise, small d form we can say, or we say plus. That's why we have given plus here. But plus indicates what here? This molecule of glucose or glucose solution will rotate the plane polarized light towards which side? Right side. How to identify plus form here? On the first chiral carbon, from lower mass to higher mass, we have to draw one curved arrow. And if the curved arrow is going clockwise,ly, that is called what now? Plus form. If curved arrow is going anti-clockwise,ly, suppose, that is minus form. Now check here in the fructose. In case of fructose molecule, again formula is same na? C6H12O6 only formula. Now here how many chiral? This is not chiral, first one. It is first carbon. It is second carbon. It is third, fourth, fifth, and sixth. Now it is not chiral. Why? Double bonded carbon cannot be chiral. This is also not chiral, first one also, because two hydrogens same here. So it is first chiral, second chiral, third chiral. So how many chiral carbons in fructose? 3 chiral. In fructose molecule, how many chiral carbon atoms available? 3 chiral carbon atoms are available here. And now again, what is the first chiral here? This one. So it is the first chiral, and this one is what? Last chiral. The fifth one is last chiral. The third one is first chiral. Now on first chiral, hydrogen is on the left side, 1 AMU, atomic mass unit, 1 AMU. And right side, what is there on first chiral? 17 AMU. 17 atomic mass unit. And now again, where to where we have to draw? From hydrogen to OH group. From hydrogen to OH group, we have to draw curved arrow. Now it is going anti-clockwise,ly, right? So whenever this curved arrow is going from anti-clockwise direction, means from hydrogen to OH group in anti-clockwise, it will be called minus form. Minus means what? LAEVO, LAEVO form. LAEVO, LAEVO form, small l, otherwise minus. That means what now here? This fructose, this minus indicates what here? Minus fructose indicates what? The fructose solution will rotate PPL, plane polarized light, towards which side? Left side. The fructose will rotate the PPL towards left side. That's why here it is minus 1. Next. Now check it here. Why D is there here? Capital D. D glucose it is. Why D glucose is that? See, the last chiral carbon, observe it. The last chiral carbon in glucose is what? Fifth atom. The fifth atom is what? Last chiral. On the last chiral, the OH group is on which side? Right or left side? OH group is on the right side here. If OH group is on the right side of last chiral carbon, that will be called D configuration. Capital D. Capital D configuration. So D configuration indicates what here? What is the meaning of D configuration? If the OH group is present on the right hand side of the last chiral carbon, that is called what now here? D configuration. That's why capital D glucose we said here. So D plus glucose. Next, you check it here in fructose. In case of fructose, you check it. D minus we said here. Why D here again? The last chiral carbon of fructose has OH group on which side? Right side. If OH group is on the right side of last chiral carbon, that structure will be having which configuration? D configuration, capital D configuration. So D minus fructose. Have you understood what is the configuration D? What is plus and minus here? So it's about what now here? D glucose, D fructose. D plus glucose, D minus fructose. So first chiral carbon will decide what? Plus or minus. The last chiral carbon in the molecule decides what? Capital D configuration, capital L configuration. D, L. In which case the L configuration we say, if OH group is on left side, if OH group on the last chiral carbon is on the left side, that will be called what? L configuration. But here, OH is on the right side, not D. Here also OH is on the right side, not that's the D. So D configuration and L configuration, two types configuration will be there. So what is the meaning of DL configuration here? The DL configuration is called relative configuration. What is the meaning of DL configuration? DL is called what? Relative configuration. So relative configuration of glucose and fructose we have to understand. Okay. Now listen, one more thing. One second. See. Now this is glucose molecule. C6H12O6 here. So here, what is the group here? This one, aldehyde. CHO, CHOH, 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 CH2OH. How many OH groups are there? Count. OH, OH2, 3, 4, 5. So 5 hydroxy groups available here. And how many aldehyde groups available? One aldehyde group is there, CHO. Okay. And how many carbons totally available here in the parent chain? 6 carbons. So it is glucose here. And now again here, what happens is that it is first chiral, second chiral, third chiral, fourth chiral. 4 chiral carbons now. Now listen carefully. Here, between fourth means between last chiral and the CHO group. Okay. So here what happens is that this hydrogen, the hydrogen on the last chiral will be shifted to what now? Oxygen. The hydrogen on last chiral from OH group. From OH group, the hydrogen of the last chiral will be migrated towards what now here? Migrated towards more electronegative oxygen. Then double bond O becomes what? Single bond OH. The double bond O became what? Single bond OH here. Got it, huh? Next, between this carbon, first carbon and last but one carbon, a O is there here. From OH group, only hydrogen migrated, na? Still O is here only. The O is here. Okay? The O is here. This O is connecting which atoms here? First atom and fifth atom. Now numbering how to give first atom, second atom, third atom, fourth, fifth, sixth. Na? Now first atom and fifth atom. Both are joined by what? Oxygen here. So this type of structure is called hemiacetal. Hemiacetal. So glucose molecule is giving what now here? Hemiacetal structure. Yeah, why we said internal? Why it is called internal hemiacetal? Within the same molecule, between first atom and fifth atom, the oxygen has been joined here now. That's why it is called internal hemiacetal structure. The same internal hemiacetal structure. Now you see, it is becoming cyclic structure. You see, it's becoming what cyclic structure. The cyclic structure contains what? Carbon. 1, 2, 3, 4, 5 carbons. Again, one oxygen. This total is forming what? One cyclic structure. 5 carbons and 1 oxygen will form what? 6-membered ring. 6-membered ring. So 6-membered ring is formed here. 5 carbons and 1 oxygen. Is that clear? Next one, check it here. See. Now the same structure is given here. The same what I said now here. First atom, second carbon, third carbon, fourth carbon, fifth carbon, and sixth carbon of glucose. Between first and fifth atoms, what is there here? Oxygen is there. See. In hemiacetal. What is hemiacetal? In hemiacetal structure, between first atom and fifth atom, one oxygen is there here. Okay. If OH group is on the right side, suppose on first carbon, if OH group is on the right side, that will be called alpha carbon. Here alpha form, alpha glucose. How to decide here? In hemiacetal structure, in cyclic structure, on first carbon atom, if OH group is present on the right side, that will be called alpha form, alpha glucose form. Now check in this second one, check it here. In this hemiacetal, in this structure now between first atom and fifth atom, what is there here? Oxygen is there, joining the first atom and fifth atom. What is there here? Oxygen is available here. Now on the first carbon, OH group is on which side? Right side or left side? It is on left side now. In first one, OH is on right side. In second structure, OH is on left side here. That's why it is called what? Beta form. Beta form means what now here? If OH group is present on the left hand side of first carbon of hemiacetal structure, that will be called beta glucose form. Beta glucose, alpha glucose. Remember. And this alpha glucose will have higher melting point. Remember. How to distinguish between these two forms? Alpha form has higher melting point and beta form has lower melting point. Melting point is greater means what? More symmetrical. More melting point indicates what for alpha form? Alpha form is more symmetrical. That's why more melting point is there. That point keep in mind. So now see, the same structure, hemiacetal structure, we can write in cyclic form. It is cyclic structure. The cyclic structure of what? Hemiacetal of alpha form. See here. Now how many carbons totally forming ring? 1, 2, 3, 4, 5. 5 carbons and 1 oxygen forming ring here. This carbon, last carbon is out of ring here. This last carbon is not within the ring. The 5 carbons and 1 oxygen forming 6-membered ring. Here, 1 oxygen is there here, 1 oxygen is there, and here it is carbon. First atom, second atom, third atom, fourth atom, fifth atom, and 1 oxygen is there here. So between first atom and fifth atom, what is there here? Oxygen is there. The oxygen is present between first atom and fifth atom. Between 5 and 1, oxygen is there here. Check it. Now one more thing, how to write this cyclic structure is that, see, on first carbon, now you take this right side carbon as first carbon. On this first carbon, if OH is on the right side in alpha form, now this OH will be downwards. OH will be written downwards like this. And H will be upwards. On the first atom carbon, on first carbon atom, OH on the right side, H on left side. Now, this right side OH will come downwards here. And left side H will go upwards. On second atom, what is OH position right side? Now, that's why OH will be downwards. H will be upwards. On third atom, OH is on left side now here. H is on right side here. On third atom, H is on the right side here. When H is on the right side, that H should go downwards here. Like this. On third atom, H is downwards. And on fourth atom, check it. On fourth atom, OH is on right side now. On fourth carbon, OH is on right side here. So on fourth atom, OH should be downwards here. Right side means downwards. Remember. On fifth atom, on fifth carbon, here right side, what is there here? Anything is not there here. Right side, anything is not there. That's why we have say what now here. The CH2OH is on not right side there. So it should be taken always upwards there. On fifth atom, the CH2OH must be written above the plane. Above the plane we have right. H will be downwards, CH2OH will be upwards. Then between first atom and fifth atom, what is there here? One oxygen atom is present. So we have to check always this position on first atom. On first carbon, if OH group is below the ring, below the plane, that should be taken as alpha form. Alpha form we have taken. It is alpha glucose. Okay. And instead of glucose, now we have to use word glucopyranose. Glucopyranose. What is the name of this? Instead of glucose, what we have to say? Glucopyranose. So it is what now here? Two types of structures are there in this. One is what alpha form, one is beta form. Now check beta form here. In beta form on first carbon, what is there? H on the right side now. So H will be below. Okay. And on second atom right side, what is there? OH is there. So OH will come downwards here. On third atom, H is on the right side now. So H will come downwards. On fourth atom, OH is on the right side now. So OH will come downwards. On fifth atom, always CH2OH should be above the plane. CH2OH should be above the plane. Then the oxygen will be joining first atom and fifth atom. So this type of structure is what now here? Glucopyranose structure. And here we have alpha D plus glucopyranose. Alpha D plus glucopyranose. And second one is what now? Second form beta capital D plus glucopyranose. A plus indicates what? Rotation towards right side. Rotation of light towards right side. And what is capital D here? The last but one carbon means the last chiral carbon has OH group on which side? Right side. So D. And beta indicates what here? The OH group on first atom of cyclic structure above the plane. And alpha form meaning what? If OH group on the first atom is below the plane. If OH group on the first carbon is below the plane, it is called alpha form. If OH group is present above the plane of the first carbon in the cyclic structure, that will be called beta form. Which one has more melting point? Alpha form has more melting point than beta form. Next again. Now again what here? Fructose molecule. Here the fructose molecule will be called fructofuranose. Furanose. Here the fructofuranose. So fructofuranose and the glucose is called glucopyranose. The glucose will resemble pyranone structure, and this one fructose will resemble what now here? Furan structure. Furan, pyron and furan. Now check it here. So again here alpha D minus alpha hyphen D hyphen minus fructofuranose. And this name is what now? Beta D beta hyphen D hyphen minus fructofuranose. Fructofuranose. One is alpha form, one is beta form. Remember. So in this case, in the case of fructose also, okay, what will be there here? The first atom of fructose, second atom, third atom, fourth atom, fifth atom, sixth atom. Now between second carbon and fifth carbon, between second carbon and fifth carbon, what will be there? Oxygen will be present. The oxygen will be present joining It will be joining what now? Second carbon atom versus fifth carbon. Okay. So again, on second atom, if OH is on the right side, that is alpha form. Alpha. On second carbon atom, if OH is on the left side, suppose on second carbon, if OH group is on the right left side here, it is called beta form. So alpha form and beta form. Our left side structure is what now? Alpha form. Right side is what? Beta form. Now you see here in the ring now, how many carbons involved? Check it. One atom is here. One atom. Second atom. Third atom. Fourth atom. And oxygen fifth atom. How many atoms in the ring now here in this ring? Oxygen. 1, 2, 3, 4 carbons. 4 carbons and 1 oxygen there. So it is what now here? Furanols. This type of structure is called furanols. Is that clear? So furanose structure is for fructose, pyranose structure for glucose. So again in this here, now here see, when you are making this hemiacetal structure into cyclic structure. The first one is hemiacetal. This is equivalent to what? Equivalent to hemiacetal is equivalent to what now? The cyclic structure. In this cyclic structure, now here first atom is here. Now second atom. Now on the second atom, if OH is below the plane, it will be alpha form. Here, suppose on second atom of the structure, if OH is above the plane, we have to say what now? Beta form. If OH is above, beta. If OH is below, alpha. That is about what now? Alpha D minus fructofuranose. It is what right side is what? Beta D minus fructofuranose. So these are what cyclic structures of fructose. The cyclic structures of fructose are called what? Fructofuranose structures. Fructofuranose structures. Next one. Suppose if glucose molecule alpha D glucose we have taken one structure. Structure 180. Structure 1 we have taken. Now here it is reacting with what now? CH3OH. What is the name of CH3OH? Methyl alcohol. Methyl alcohol is also called what? Methanol. 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 So methanol or methyl alcohol we have taken in presence of a dry HCl gas. In presence of dry HCl gas, when glucose reacts with what? Methyl alcohol. Now what happens? You check it here. Now here in this CH3O is there here? CH3O. Now here see the OH group. The OH group will become what now here? OCH3. The OH group becomes what? OCH3. Hydroxy group will become methoxy group. The OCH3 is what now? Methoxy. Methyl and oxygen, methoxy group. And OH group is called what? Hydroxy group. So hydroxy group is replaced by what? Methoxy group here. Okay. Next. So here what happened now? OCH3 group is on which side now? Right side here. OCH3 group right side means which form? Alpha form. Next. Suppose if you take beta D glucose, the second structure if you take, suppose, again we are reacting with what? CH3OH. With CH3OH, methyl alcohol in the presence of dry HCl gas. Now here what happens? Check it here. In this case, the methoxy group is on the left side of this carbon. On the left side, methyl group is there, methoxy group is there. So that's why it is given what now here? Beta form. The first one is called what? Alpha D methyl glucoside. Glucoside formation we say this one. Glucoside formation. So methyl glucoside is formed. Alpha D methyl glucoside. And second one downwards what now here name? Beta D methyl glucoside. Beta D methyl glucoside. So these are important reactions of what now here glucose. Okay. Next. Now generally furanose we said now fructofuranose and glucopyranose. A pyron means what? 6-membered ring. It is like this here. Now here is 6-membered ring with 2 double bonds and oxygen. And furon. Furon means what? 5-membered ring. 5-membered ring with 2 double bonds. The 5-membered ring with 2 double bonds and 1 oxygen. Here it is 6-membered ring with 2 double bonds and 1 oxygen. So pyron, furon. So glucose resembles what? Pyron. So it is called glucopyranose. And fructose resembles what? No, furon. That's why it is what now here? Fructofuranose. And formation of glycosides. So when treated with methyl alcohol formula what we discussed now just now, CH3OH. So when treated with methyl alcohol in presence of dry HCl gas, glucose yields means what? Produces. Glucose will produce monomethyl ether. Monomethyl ether will be produced here, which is actually a mixture of what? Alpha and beta forms, indicating that one of the hydroxy groups is different from other hydroxy groups. In glucose and fructose, many hydroxide groups are there now. So one hydroxy group will be different from other hydroxy groups. This can be understood by the formation of glycosides or glucosides also we can say. Glucoside or glycoside. Okay. Out of many hydroxy groups, OH groups, one OH group is different from other groups. Okay. And this supports what now? It supports that glucose has a cyclic structure. You can understand that glucose has cyclic structure. Suppose the glucose molecule, generally we write what? C6H12 O6 we write. The same thing how they wrote this, how they wrote here C6H11, okay, O5 and one O and one H, OH. OH is taken. C6H11O5 bond OH they have taken. The same is glucose. So this OH group of glucose molecule will combine with the H. It is what? Methyl alcohol. What is this? Methanol. So with this methanol means with hydrogen of methanol, the OH group of glucose combining. OH and H will form what now? H2O. H2O is formed. Then this OCH3 group, that is methoxy group, will be substituted in the place of OH here. In place of OH, what will come? CH3O. So in place of OH, what has come? CH3O. So it is what now here? Alpha and beta, both will be there in this. Alpha form and beta form, both will be present here. So it is what now? Alpha, beta, methyl glucoside. Okay. It is glucoside formation or glycoside formation. This. Okay. So it is about what now here? This. So OH is on the right side here. OH is on the left side. So if OH is on left side, it is beta. If if CH3O is left side, beta. If CH3O is right side, alpha. And see, alpha form has what? 438 Kelvin melting point. And beta form has what? 380 Kelvin. So which one has more melting point here? Alpha form. So alpha form has what? More melting point. And here the specific rotation. Alpha D means what? Specific rotation. The specific rotation is what now? Plus 158 degrees. Means plus indicates for rotation towards which side? Right side. So this alpha form will rotate the plane polarized light towards what? Right side by how much angle? 158 degrees. And here, if you take beta form, alpha D means what? Specific rotation. D means D line. Some D line will be used here, wavelength. So alpha D means specific rotation of this beta form is equal to how much now? Minus 33 degrees. A minus sign indicates what? This beta form will rotate the plane polarized light towards what? Left side. Towards the left side. Is the concept clear to all? So it's about what now beta form and alpha form. These are important areas. Now preparation of glucose by laboratory method here. Suppose here, if you take glucose preparation, glucose can be prepared in the laboratory by the reaction of what hydrolysis of cane sugar. Cane sugar means sucrose. So it is the hydrolysis of cane sugar will give what? Glucose. Okay. So it is one of the important methods of preparation here. Okay. It is called inversion of cane sugar. Inversion of cane sugar will produce what? Glucose and fructose. Like this, glucose can be prepared here. Okay. And here, what is more soluble between these two? Fructose. Fructose more soluble in solution here. Glucose is less soluble. When you compare with glucose and fructose, glucose being much less soluble in alcohol than fructose separates out by crystallizing on cooling what, leaving behind more soluble fructose in solution. In alcohol, which is more soluble, fructose is more soluble than what? Glucose. In this way, we can separate what? Glucose and fructose from each other by using what? Alcohol solution. So it's about what now here important areas of carbohydrates. And next one, manufacturing means what? Preparation of glucose on large scale. On large scale, glucose can be prepared from what now here? Starch. The starch can be obtained from where? Corn starch, potato starch. In some areas, sugar cane will be taken here. So corn starch, potato starch will be used here. What is starch formula? C6, H10O5 taken n times. It is interacting with n number of H2O molecules in the presence of acidic medium and heated. Then we are getting what? N moles of glucose. So glucose can be prepared on large scale from starch. It is what here manufacture of glucose. Okay, so it's about one of the important area of this one. And these all things will be sent to you. Please go through each and everything and note down important points.